Nestled deep in the Blue Ridge foothills, the Etowah River begins as little more than a whisper. Its name, Etowah, comes from an early Muskogee Indian word meaning place of many people, a reminder that human stories along these waters stretch back thousands of years. As the small mountain stream enters the open valleys, it gathers the waters of countless springs and branches flowing in from the hills. What began as a whisper becomes the Etowah River, stretching for more than 150 miles through deep forests and open meadows. Long before roads or towns, indigenous communities lived along the Etowah, shaping their lives around the river's seasonal rhythms. The river provided fertile soil, steady water, and access to trade routes that connected communities across the region. The mounds and artifacts they left behind reveal a sophisticated society that thrived here for centuries, evidence that the Etowah has long been more than a stream. It has always been a force shaping how people lived, settled, and survived. By the 1830s, indigenous communities were forced from the Etowah Valley, and the land quickly opened to new settlers. Drawn by fertile soil, rich timber, and the steady river, families established farms and homesteads. By the mid-19th century, those settlements led to one of Georgia's first major industrial centers, the Etowah Iron Works, expanded by Mark Anthony Cooper into a sprawling complex supplying iron for industry. At its height, it was one of the largest operations of its kind, powered in part by the river that flowed beside it. The Etowah was no longer simply a source of water and farmland. It had become an economic artery, supporting agriculture, transportation, and industry across the region. In the decades that followed, life along the Etowah River settled into a quieter rhythm. Families worked the fertile bottomlands, and small mills and ferries served the communities along its banks. But the Etowah River was unpredictable. Heavy rains could send walls of water downstream with little warning. Floodwaters spilled over their banks, sweeping away crops and drowning livestock. Roads disappeared beneath muddy currents, homes were damaged or destroyed, and entire communities were cut off for days at a time. These were not isolated disasters, but recurring events, season after season, decade after decade, reminding residents that the river's power could not be controlled. By the late 1930s, the need for flood control and a lasting solution had become impossible to ignore. Washington took notice. The Flood Control Acts of 1936 and 1938 launched the first national effort to manage dangerous rivers. In 1941, as storms and rising waters continued to batter the region, Congress passed another Flood Control Act, renewing support for new dams and reservoirs. Momentum for an Etowah project was growing. But just as the nation prepared to act, the world changed. On December 7, 1941, the attack on Pearl Harbor brought the United States fully into World War II. Almost overnight, steel, machinery, and manpower, everything needed to build the dam, were redirected to the war effort. Skilled workers who might have poured concrete or operated heavy machines were called into service, and every corner of American industry shifted to support victory overseas. The Allatoona project was quietly set aside, and through the war years, the Etowah flowed on as it always had. World War II ended on September 2, 1945.
Throughout the world, throngs of people hailed the end of the war in Europe.
In February 1946, the Allatoona Dam project was officially revived. Engineers unrolled the pre-war plans, and survey teams returned to the valley. With the nation at peace and resources finally available, the transformation of the Etowah Valley could truly begin. What had once lived only in the margins of federal planning was now a full-scale project. The first changes in the Etowah Valley came quickly. In early 1946, clearing began. Thousands of acres of forest and bottomlands cut and cleared to prepare for the future reservoir. Timber crews worked through the floodplain, and heavy equipment arrived as the landscape was reshaped. The quiet river valley that had endured for generations was now entering a new chapter, its shape, purpose, and future being transformed piece by piece. In the months that followed, the work moved from clearing the valley to building the massive work site required to construct the dam. New access roads were carved into the hills to move equipment and labor to the dam site. Barracks and temporary housing rose nearby to support the growing labor force, and storage yards were laid out for steel, timber, and machinery. To supply the vast amount of concrete the dam would require, a large mixing plant was built above the site, along with a gantry crane to move materials into place. An entire support system, roads, utilities, and work platforms took shape before a single yard of concrete could be poured. In April of 1946, the U.S. Army Corps of Engineers awarded the primary construction contract to National Constructors, Inc. They brought hundreds of skilled laborers, engineers, and equipment operators to the site, ultimately employing more than 1,000 workers at the project's peak. With the infrastructure established, excavation of the dam site began in earnest. Crews drilled deep into the valley floor, set blasting charges, and removed thousands of tons of earth to expose the solid bedrock needed to anchor the dam. Engineers analyzed core samples and tested the exposed rock to confirm its strength and stability, guiding every cut made into the riverbed. To keep the Etowah from flooding the worksite, cofferdams were built across the river, massive temporary walls of earth, rock, and steel. Once complete, they forced the river into a narrow diversion channel, leaving large portions of the riverbed dry for the first time in memory. By the end of the year, the transformation was unmistakable. What had once been a quiet floodplain was now a sprawling construction site. As 1947 began, the work at the dam site shifted from excavation to preparation for construction. Crews finished exposing and leveling the bedrock, shaping the basin where the spillway and powerhouse would stand. Carpenters assembled the first timber forms, compressors and mixers were positioned, and the site took on the orderly shape of a construction platform. By late spring, everything was ready. On June 7, 1947, the first concrete was poured into the dam's foundation, an event marked across the project as the moment Allatoona Dam truly began to rise. The pace at the dam site accelerated into a continuous 24-hour cycle. The mixing plant ran day and night, sending a steady flow of material to the forms as the first layers of the dam took shape. As construction advanced, attention turned to what would soon disappear beneath the reservoir. Beginning in late 1946, archaeologists moved through the Etowah Valley ahead of the rising water, working quickly to recover what could be saved. Small teams located and documented nearly 200 archaeological sites, collecting and recording artifacts, pottery fragments, stone tools, and other material evidence that preserved thousands of years of human history before the landscape disappeared beneath the reservoir. Surveyors mapped the historic valley itself, farmsteads, roads, bridge crossings, and community sites that had shaped daily life for generations. As the water rose, much of that landscape vanished, preserved only in records, photographs, and memory. Allatoona Dam was built in individual blocks called monoliths, massive concrete sections that allowed the structure to rise evenly without cracking. Each monolith was formed lift by lift. Crews set steel reinforcing bars, assembled timber and steel forms, and guided fresh concrete into place using cable-mounted buckets hoisted by the gantry crane. Workers then inserted immersible vibrators into the wet concrete to remove air pockets and consolidate the mix, and the tops of each lift were roughened to bond with the next. As the summer went on, the foundations of these monoliths began to rise above the riverbed. As the concrete cured, managing its heat required constant attention. Crews installed embedded cooling pipes, hollow steel tubes that carried cold water through the interior of the monoliths. These pipes drew heat away from the concrete as it cured, allowing each block to harden slowly and evenly. By this time, the dam was drawing attention far beyond the Etowah Valley, with hundreds of visitors arriving daily and weekend crowds swelling into the thousands, many driving hours just to catch a glimpse. Newspapers up and down the East Coast carried photographs of cranes, cofferdams, and rising monoliths, turning Allatoona into one of the most closely watched construction projects of its time. With the foundations secured in bedrock, work shifted to the powerhouse and the massive water conduits that would drive the future turbines. At the upstream face of the dam, crews installed the pre-built bellmouth forms, the wide, flared openings that would smooth the flow of water entering the hydropower system. Behind them, carpenters shaped the curved gooseneck passages, the downward sweeping forms that transition from the bellmouths into the steep, steel-lined penstocks embedded deep within the dam. Thick, high-strength steel plates were fabricated on-site into curved sections called cans. Welders joined each section, and every weld was inspected by X-ray radiography. One by one, the cans were assembled and carefully aligned to form the 3 penstocks. Meanwhile, the powerhouse foundation grew around the turbine pits. By the end of 1947, the initial monoliths were taking shape across the valley floor. Their outlines formed the first visible row of Allatoona Dam, firmly anchored in the bedrock and signaling that the structure was now truly underway. Allatoona Dam is a concrete gravity dam built to hold back the Etowah River. Behind it, water from the reservoir enters the dam through intake openings and flows downward through large internal passages called penstocks. As the water moves through these penstocks, gravity drives it toward the powerhouse, where it spins turbines connected to generators, converting the river's motion into electricity. After passing through the turbines, the water is released back into the Etowah River below the dam. Gates and controls regulate this flow, allowing the dam to manage floods, generate power, and guide the river safely through the structure. In the spring of 1948, construction reached another critical stage. Engineers declared the project halfway complete, marking both the physical progress and the momentum driving the work. With the central portion of the dam taking shape, engineers rerouted the cofferdams to direct the Etowah River through a controlled opening between monoliths 14 and 16. This opening allowed the river to pass safely through the structure, while concrete work continued on both sides. With the waters redirected, construction expanded outward through the remainder of the year. The remaining monoliths started their early lifts, quickly rising as crews worked to establish the dam's full footprint across the valley. As 1948 drew to a close, the river still flowed through its engineered opening, but the structure around it was steadily taking shape, bringing the project closer to its final form. Building the dam was dangerous work. Newspapers recorded some of the cost. Laborers were killed in falls. Heavy trucks hauling equipment collided with civilian vehicles. Crane and heavy equipment failures sent tons of material crashing into the work zone. Ice storms slicked scaffolding and walkways, and all too common floods surged through the river channel, testing cofferdams and forcing urgent retreats. But not every injury or every death was recorded. Beyond the headlines, there were countless accidents, near misses, and injuries that never reached the papers. The true human toll of the project, both direct and indirect, may never be fully known. By the spring of 1949, the concrete monoliths were largely built out to their intended height, forming a continuous wall across the river. While finishing work continued along the crest, the dam's overall shape was now clearly defined. Work intensified around the powerhouse and switchyard throughout the end of 1948 and into mid-1949. Concrete walls closed in around the turbine pits, and floors, galleries, and service levels were formed. What had once been open excavation became a complex interior, engineered to support the machinery that would soon be installed. Large steel components arrived by rail and truck and were lowered into place piece by piece. Turbine components and generators were assembled. Gate hoists, powerhouse crane, and control mechanisms were installed to regulate the future flow of water through the dam. Generator stators, fixed outer frames that would create electrical current, were set into position. Rotors and vertical shafts aligned within the turbine pits below. Each piece required precise alignment. Across the crest, finishing work continued steadily. Overflow monoliths were completed. Bridge piers rose into position, and the roadway spanning the dam took its final shape, connecting both sides of the valley. Railings, surfaces, and access points were installed as crews worked methodically from end to end. In the switchyard, transformers, breakers, and control equipment were installed and tested, preparing the system to handle future electrical loads. By December of 1949, the powerhouse, switchyard, and crest were largely complete. In February of 1950, Allatoona reached a long-anticipated milestone. Water was allowed to flow through the turbines, and for the first time, the dam produced electricity. Attention now turned beyond the dam itself, to the valley upstream and the changes the rising reservoir would soon require. Across the future lake basin, crews hurried to complete a network of impounding dams, smaller, earthen and concrete structures built across tributaries and low valleys to contain the rising waters and shape the reservoir's edges. Low-lying roads were rerouted or abandoned, and new bridges were constructed where crossings could not be lost. That same year, the lake began to open to the public in limited ways. Boating, fishing, sightseeing, and picnicking were permitted along newly accessible shorelines, offering the first glimpse of how the project would serve not just industry and flood control, but everyday life. What had begun as an engineering project was now becoming a public place, setting the stage for its formal dedication. On October 16, 1952, Allatoona Dam was formally dedicated. Leaders gathered atop the structure that had transformed the river and reshaped the Etowah Valley. Lieutenant General Lewis A. Pick, Chief of Army Engineers, called the project an outstanding example of cooperation between federal, state, and local interests. Today, the scale of the project is unmistakable. The concrete dam stretches 1,250 feet across the valley and rises 190 feet above the river, built with nearly 500,000 cubic yards of concrete. Behind it, Allatoona Lake spreads across the landscape, creating more than 270 miles of shoreline. Inside the powerhouse, 3 generating units can produce a combined capacity of 82,000 kilowatts of electricity. Built at an original cost of approximately $32 million, the project unifies flood control, power generation, and water management. The lake now supports hundreds of campsites and picnic areas, along with parks, marinas, and public access throughout the region. Today, Allatoona Lake is one of the most visited Corps of Engineers lakes in the nation, welcoming nearly 7 million visitors each year and contributing close to $250 million annually to the regional economy. The Etowah River still flows from the mountains through the valley it has always shaped. Guided by Allatoona Dam, its waters now serve many purposes, but the river endures and its story continues.